Let's build our intuition for the graph 1 over x by actually plotting it. So first, I'll calculate a bunch of key points. The main interesting thing here is that when the input is 0, the output is not defined because you can't divide by 0. Let's go ahead and plot that. Okay, so if we're ignoring the mystery zone in the interval from -1 to 1, we see that as x values start at 1 and get larger, the y values are getting smaller and smaller, but they're approaching 0, and they're never getting there. So that's why you have a horizontal asymptote at y equals 0, and you can see that behavior here. For negative inputs, the exact same thing is happening, only the outputs have to be negative. So we start at -1, and they're getting larger and larger, approaching 0 from the negative side. Okay, so what's happening inside this mystery zone? Let's plot 2 more points. So if I plot the point at x is 1/2, 1 divided by 1/2 is the same thing as 2. So 1 divided by -1/2 should be -2. So adding those points to the graph, we have one here and we have one here. You might notice that this is symmetric with the case where x is 2 and y is 1/2. Here we have x is 1/2 and y is 2. And if you think about it for a minute, you should see that this symmetry is going to continue to happen. So, well, I didn't leave enough room in my table here. What if we plug in an x value of 1/10? So that's very, very close to the y-axis here. So here would be 1/10. 1 divided by 1/10 gives us 10. So that's going to give us a point way up here. So hopefully you can see that as my x values get closer and closer and closer to 0, my y values are going to get larger and larger and larger, approaching infinity. So you've got another asymptote, this time a vertical one, right at x equals 0. And a similar analysis applies to the negative side. The only difference is that all of the outputs are negative. So instead of positive 2, you have -2. Instead of positive 10, you'd have -10 way down here somewhere. So in the end, you get these 2 kind of symmetric arcs, which are perfectly symmetric around this diagonal line. Also, I suppose, around this other diagonal line. If that last part seemed a little fast to you, go ahead and redo the same idea yourself in a table. Let's imagine x values that start at 1 and get closer and closer to the x-axis. So here's x equals 1, 1/2, 1/3, 1/4, 1/5, and so on. Closer to x equals 0. Then figure out what should the output be, and go ahead and make your own plot and kind of see that this expression is forcing the y values towards infinity as your x values approach 0.